All right, good morning, everybody. Afternoon to those of you who are on the East Coast. Welcome to PCS Adventures and our webinar. My name is Robert Grover, and this is Randy Jameson. We'll tell you a little bit about ourselves in just a minute. Our agenda for today is on the screen in front of you. You should be seeing a slide that has 10 bullet points. We're going to be talking a little bit about Randy's formative experiences to give you some idea of the impressions that he had when he was young and the things that occurred to him as he learned how to code and the impact it had on him as a youngster. We're also going to talk about statistics of what's going on in the workplace, why we need to get more computer science into the workplace. And we're also going to talk a little bit about girls, gender issues in terms of getting more girls involved in STEM. And then we're going to talk a little bit about some approaches for you to get more computer science into the classroom. So let's get started. First of all, Randy, owner and founder of a company called Curious Media, was actually my very first student some 25 years ago. And PCS Adventures has been around a long time. We literally began in the garage of a school teacher back around 1986. And Randy at that time was about 12 or 13 and was one of the founder's students. The founder's name was Pat McShane. I had volunteered to go out and meet Pat and learn some things about PCS and how he was teaching. And my interview basically was walking in to his after-school program, and Pat just pointed at this kid sitting over at a table. It was Randy, and he said, "Hey, go work with that kid." So I think he wanted to see how well I interacted with students and what kind of rapport I would generate. So that was my very first experience with teaching a live student. I do not have a background in education. I've got degrees in English and business, but a lot of hands-on experience going through a number of programs with PCS and teaching in that after-school environment for years. So Randy, I'd like you to tell a little bit about what you remember about PCS from those early years and maybe a little bit about how you think it might have impacted you.
All right. Yeah, so I think what I remember about PCS, I first heard of PCS on the bus ride home shortly after I moved to Idaho. And it sounded awesome. I'd always been interested in computers, spent a lot of time playing games on Commodore 64, and I just wanted to know more about being able to make something like that. I've always been interested in that type of thing. So my parents were gracious enough to get me signed up at PCS, and I think what I liked about it is that there were so many different directions to go. They had the Legos and engineering, and there were some people there working on electronics, designing boards, and computer animation, and that's the one that really sparked my interest, was the computer animation. I love to doodle, I love to draw all over my school papers. My teachers weren't too appreciative of things that I drew instead of doing my homework. But I got the last laugh because I turned it into an occupation. And so I guess one of the things I remember about PCS, one of my first animations was the profile of a nose sneezing, and that was good memories, and also just the being open to all the different possibilities that directions that I could go with programming or I guess computers in general in the line of things that I was interested in. So.
Yeah, so one of the things that, you mentioned PCS doing a lot of different things when you walked in the door, and that was one of the things that really drew me to PCS, because it wasn't just computers, it was engineering, it was electronics. There were a lot of things going on, and students that would come into that environment. It was like a makerspace of the 80s. It was before makerspaces, were around, because you were doing so many different things, inventing. So that was one of the things that really struck me, and I think that exposure to a lot of different subjects is a much richer experience than if you were just focusing on programming.
I actually would add to that, in my current line of work, Robert asked me to write a bio or about my experience at PCS a couple of years ago, and as I was writing it, it struck me that everything that I came into contact with at PCS is something that I use on a regular basis, and that included animation, computer programming, mechanical engineering, electronics engineering, and laser beams.
You've always got to have lasers.
Yeah.
So this next slide that I have up, when I was interviewing you the other day about some of the things in computer science that really piqued your interest, you've mentioned a couple of them already, but I actually put your quote up there. You said having good experiences with computers and being comfortable. And then you mentioned some applications. You talked about the Commodore 64. What else was there? There was Scorched Earth. Tell me a little bit about what you remember inspiring you more towards computers.
So when I was in early elementary school, I always wanted to go to the library to play on the computers, and that was, I think, probably my first experience with computers. First and second grade, going into the library, playing on a screen with green pixels, and it was like I think it was like a Snoopy Flying Ace game that required some kind of math. I can't remember what it was. And then also a Scorched Earth type of game where you had to be able to lob a projectile to a certain place, and you had to control the angle and the velocity, and you have to calculate wind speed and all that type of thing. And I remember always asking my teacher if I could go play on the computer, and she would correct me. And don't ever do this to your students. If they think that being on the computer is play, let them believe that. Because she said, no, you can't go play on the computer. You can go work on the computer. And I don't think I've ever worked on the computer. So.
Good perspective. So another thing you had mentioned when we were talking was it really, a lot of the applications you were doing, probably something like the Scorched Earth, really showed you the reason for math. And when you were doing math homework and things like that and studying, algebra equations, you could not for the life of you figure out why on earth do I need to know this.
Yes.
But a lot of that became illuminated with computers.
Yes. So yeah, my first and second year of algebra, I hated it. I couldn't understand why you couldn't just tell me what x was. Like, why do I have to figure out what x is? That makes no sense to me. I didn't see the application. It didn't fit into anything I was interested in. And there were no answers as to why that was something important for me to know. And without knowing the application, it was difficult for me to be passionate about it. Later on in life, when I started doing more programming, and I discovered that well, let me pause for a moment on that train of thought. I'm an artist first, and just I guess an entrepreneur after that, or I'm just curious about all types of things. But firstly, I'm an artist, and when I could see that I could take algebra and apply it to art and make something that moves and interacts, it was so exciting to me. And I just remember thinking, like, why didn't they tell me this in junior high when I was learning algebra? Why couldn't it have been applied to something fun and exciting, that I could see the application and I could be passionate about it? And I feel like I would have liked to have gone back in time knowing what I know now, so I could maybe apply myself better back then.
How old were you when you had the lights go on about algebra? What grade was that in?
It was, I was out of school
You
by
were
then.
out of school by then.
Yeah.
So, another formative experience you'd talked about, and you'd mentioned it a couple times here, was your first interactive animation that really lit things up for you when you realized you could control things. Can you tell us a little bit about that experience?
Yeah, so there was an application several years ago for Macromedia called Director, and you could take animations and apply programming to it, and then use input like your mouse or keyboard to control those animations that you made. And so my first animation was an animation of a little kid, and if you clicked on his face, he'd like grab his top lip and pull it up over his head, and it revealed his skull. And you could add sound effects, and it was just delightful to me.
That sounds like fun.
Yeah.
So, at what age were you, was most of your actual development when you were starting to get into more sophisticated things like that? By the time you got out of school, is that when you started working in director and those kinds of areas, or did you
Yeah.
get some exposure in school?
Well, I didn't get any exposure in school. It was all after the fact. In '96, started working for a company in Nampa that was just getting into desktop publishing and also internet development in its early days, and that was all just very exciting to me. Could see the application. I could also see that I could potentially make a living at doing that.
Awesome. Yeah, so there's a nationwide movement towards computer science standards and to get more computer science embedded into the curriculum, which can be challenging for people because teachers are already overtaxed with getting things into the classroom and into their schedule. But a lot of the things you're talking about would naturally augment the core curriculum that they're working on. It would make math more exciting, for example. Can you think of other areas aside from math that computer programming and some of the things you've done actually bring more life to?
Yes.
If I put you on the spot.
Yeah. I'll just try to talk about in my realm at Curious Media what we do. I mean, I could see it apply to, if I'm understanding your question correctly. Maybe if you could just restate your question real quick.
Actually, I think we're going to get to it here
Okay.
in another slide after next when we actually talk about what computer science helps stimulate within the classroom. And I've got another question for you when we get
Okay.
there. So the last thing you had just mentioned a few minutes ago was that you realized you could make a living out of it, and this was after you got out of school. But tell me a little bit about the aha moment when that came to light. The slide I have up, by the way, people, are some of the applications that Randy's company has developed for major clients around the country. He works with Disney, Warner Brothers, a lot of folks, PBS. So world-class clients and world-class work. So tell us a little bit about that, Randy, and how the lights went on and what
Okay.
happened.
Well, I'll try to shorten it. It's a really long story, but it started with art. Art was my passion, and I think maybe just to expand on that real quickly before I go on is I think being able to find your passion and be able to apply technology to your passion is going to make magical things happen. And so my passion was art. I thought I was going to do special effects for horror movies, but then I discovered that fine art was something that I could make a living at. I had an art show at a gallery just in high school at the end of my senior year, and I sold all my pieces and got commissioned to do more work. And I later in life went and worked for that guy doing illustration. Of course, I didn't have. I think I went to school for 2 months at BSU, dropped out to do other things, and when he hired me, I was doing illustration, very little illustration, but he had me cleaning up after the skunk that lived in the studio, doing the dishes, mopping the floors, painting, sanding, doing some construction work.
There's some real world skills.
Yeah, I was building character, I think. And so cleaning the magpie cage and polishing all the leaves individually of the plants. And so I got pretty tired of that, but there were all these computers around, and the awesome thing there was that I had an opportunity to jump on a free computer whenever I had the chance and learn more. And I already had an aptitude because of PCS that really helped to promote that in my life and my interest in it. And then when I started working on illustrations and desktop publishing and getting into web development in the early days, is when I realized, man, I could make a living at this. I really enjoy it. I get paid for it, and I don't have to clean up after the skunk anymore because I'm too busy on the computer. Sorry, skunk.
That's some incentive for sure. So thanks for that. Thanks for sharing that. This next slide is, it gets back to what we were talking about. What are people acquiring in terms of knowledge and skills when you're doing computer science in the classroom? So a lot of your early experiences with comfort and fun, I think you were blessed because you had PCS, so you had access to a lot of things that weren't going on in the classroom at that time. And that's a lot of the main challenge that's going on now as well. We're so busy with core curriculum issues that room for getting computer science into the elementary classroom or in the middle school or high school curriculum, it's difficult to do. And I think the things that you're talking about that have been formative experiences, those are much stronger if you can get them actually embedded into the daily school experience. So the slide I have up now talks about some of the things that computer science promotes. It's not just learning how to program. There's this whole rich experience of educational things that happen with students, in terms of building creativity. Randy's talked a lot about creativity and being able to explore his artistic side. The comfort and awareness of just technology in general. Our entire culture is now digitally driven, and for students to be technologically literate and comfortable within that culture, they really need to understand some of the basics of what's driving it. Now, that doesn't mean everybody needs to be a computer programmer or an engineer, but you should understand a lot of the logic and the things that are going on behind the scenes. It makes things much more relevant and much more, I think it makes a student much more successful when they're going into the work environment, regardless of what job they might take on. So some of the other things that we've talked about, or the other things on the list, so problem solving, a big one. There's a term called computational thinking that you'll see a lot referenced when we're talking about computer science standards or the things that students are learning. Computational thinking is really problem solving. It's taking a individual problem and being able to break that down into individual chunks and being able to identify, for example, the numerical operations or data that's involved in those chunks. How do I solve a problem by breaking it down into chunks and applying, the mathematics or the problem solving, the logic that needs to take place to solve that problem. When I was talking to Randy a little while ago, he had a great example of computational thinking. He didn't realize that's what it was called at the time, but I'll let you tell the folks a little bit about that because it's a perfect example.
Yeah, so one of the really exciting things to me when I started experimenting with this idea was being able to animate programmatically. So it's not frame by frame hand-drawn animation. It's changes over time on properties of an object. So let's say you take a ball and it has in 2 dimensions, it has some properties. It has color, alpha, which is like how transparent it is. It has X position, Y position, it has X scale, it has Y scale, and seeing all of those properties of that object as kind of standalone properties where I could affect those with a function. So let's say I wanted the ball to move from the left side of the screen to the right side of the screen. Well, I could write a function that says, okay, take X, the X value of this object, and 30 times a second, I want you to increment its value by 1, and that will move the object across the screen. And then I could say, well, as it's moving across the screen, I want it to go up and down. So I write another function and apply it to the Y position of the ball. And now it's moving up and down as it's moving across the screen. And I can do the same function with color and scale, X scale and Y scale. I can also affect those variables with mouse movement. So not only is it increment a number, but let's say you divide that output by the position of the mouse. Now you have an interactive animation. And again, that's another level of interest for me, was not just having something play, it's a static thing. You could actually move your mouse or have some sort of input that would affect the animation. And anyways, that's what apparently is computational thinking.
That's awesome. Yeah, that's a term that I think a lot of people are confused on. I think that's a great example. So some of the other things that computer science promotes, persistence. PCS Adventures has some private learning labs that kids attend after school. And we use a framework called the Habits of Mind. And there are 16 habits of mind, which I call the 21st century skills, essentially. And some of those are things like persistence, learning how to accept failure and go on. Failure-based learning is critical in terms of students becoming able to take responsible risks, explore, experiment, and succeed. And that's a lot of what the approach should be in computer science. You're not going to break something. Programming should be an exploration. It should be fun. It should be something that, even though things are going to fail, you should have enough successes and wins that you want to get to the next step. So that's one of the things that makes, I think, computer science in the classroom successful.
Can I tell a story about that one too? This is one of my favorites. I like to instill this in my children. Hi Jubilee, hi Piper, hi Finnegan, if you're watching. Anyways, persistence is important. One of my employees came to me, or actually I came to him, and there was a problem that he was trying to solve, and he wasn't able to get it. And he'd been working on it for a couple of days, and he told me it's impossible. I don't think we're going to be able to do it. And I kind of went out on a limb a little bit, and I said, so you're telling me that you almost got it, right? And he gave me that look. And sure enough, about 2 hours later, he had it. He had solved the problem, and because of persistence. The thing I like to say about that is if you're not failing at something, you're not trying hard enough.
Yeah, I think that's a perfect summary of what we try to instill in our students is, things are going to fail. Your robot's going to fall apart. Your electronics might smoke. Your code might work, but you got to keep pushing through. That's how all the great innovations and successes finally happen. Applied mathematics is the last one on that list. Obviously, we've talked a lot about math and how it's applied within computer science. So again, there's a lot going on in computer science as a topic. So it's not just teaching a student how to write code for a job. It's actually building a student that's able to problem solve and thrive in the 21st century, because the skills that we're teaching students today need to match what the jobs are going to be in 10 years. And we don't know what those jobs are going to be. So academically, you can't really prepare somebody rotely for what that job is going to be. What you have to do is prepare students that are going to be comfortable in solving problems, jumping in, and figuring out what it's going to take to get things accomplished. So with that in mind, we're going to move into the next section of this webinar, which is talking a little bit about the workplace and what companies are looking for, especially when they're looking to hire people in computer science areas. One of the really interesting things that I've noticed working with Randy is that he has a very applied way of interviewing and finding talent. And I wanted him to talk a little bit about that. We've got 2 slides that talk about his process. And this first slide is talking about what I think are the most critical aspects that relate back to 21st century skills. And I'll let Randy talk a little bit about this first piece.
Okay. The thing that I look for in an employee, whether it's a developer, illustrator, animator, designer, project manager, is that they have talent and that they have passion. You can have passion, but without the talent, it's not all that useful. And then same goes for the other way. If you have talent but not the passion, again, not as useful. And so what I look for in a good employee is somebody that has both of these things at their core. And if they have them, then there's gonna be evidence that they have the talent and the passion. And what the evidence is that they spend their free time. This is something that they're going to spend their free time doing, developing their talent or their passion. So if somebody comes in and they say, I want to be an animator, and I say, awesome, can you show me some things that you've done? And they say, no, I haven't done anything. Or we had one kid come in and say, no, but I have some friends that do, and they installed some software on my computer. I don't know what it is, but it's on my computer. And then I asked him if he had any illustrations he could show me, because sometimes, a lot of the times, illustration and animation kind of live in the same part of the brain. And so I asked him about any drawings or illustration, if he had any of those to show us. And he said, no, but sometimes my friends draw on the whiteboard and take pictures. So obviously that kid didn't have talent or passion. Not really sure why he was there, but when somebody comes in and they show me something that they've been working on, and it's whether it's awesome or not, it shows me that they at least have the passion, and it's going to be awesome if they also have the talent. And so I think that's what we're looking for. And a degree isn't necessary. A degree doesn't tell me anything. I like to look at the work. What have you done? And that'll tell me a lot.
Yeah. Yeah, I thought that was interesting when you said you don't necessarily, look for degrees. You're looking more for the talent and the passion. There's a interesting book out that I actually put on the slide, because the first two things that Randy talked about, when I asked him, how he finds people, he talked about talent and passion, and that's the focus of this book called The Element. It talks about that magical intersection point where talent and passion intersect. If you as a human can find that point where your talent, the thing that you're really good at, happens to intersect with something that you really enjoy, you're going to be successful for life. This book is a great read. It's by Sir Ken Robinson. He talks a lot about creativity, but the case studies in there, he brings to light things like people who were failures but went on to become world famous musicians, athletes, artists, and it all occurred because they found that magical intersecting point. And I think finding that point, a lot of it is environment. You want to create a learning environment where students have the access to a lot of things that they can experiment with and see.
Yeah, and I'd just say that, echo that, in that having the opportunities is huge, because it allows the kids to discover their passion. There's a lot of things that I've come to find out over time that I'm passionate about that I didn't know without having that opportunity available.
So let's talk a little bit more about your job process. I see we're starting to get a little tight on time, so we'll pick up the pace a little bit. But you've got like 3 or 4 other things. You already talked about your working examples. Tell us just a little bit about the job skills specifically that you look for.
So I'm looking for people that can deliver on time. So it has to be quality, a quality deliverable. So not just timeliness. And then I'm also looking for somebody that can be really organized, because we, not just with their code, but in general, because we have certain ways we have to save our files so that it gets backed up, and that other employees can get to it and find it and everything. So without any kind of organizational structure, with the size of the company that we are, it would be a mess. So it's important to be organized. Yeah, I already talked about the interview. The working examples really tell me a lot about their true interest or passion. And then also my favorite interview question is, what is your favorite animal? That tells me a lot too.
Really? Yep. Excellent. All right. So one of the things that we've talked a lot about, Randy and I, over the last week while we were discussing this webinar, is his challenge in finding talent. And that speaks to also why we want to get more students involved in computer science early. So I've got some statistics on these next 2 slides, this one and the next one, that talk about, what does the job and workplace environment look like. These are from a site called code.org, which is in the resources at the end, but has some great statistics, great insight into what's going on in the workplace. You'll notice on the slide here that it's showing, of all of the students in science and math related subjects, only 2% of those are pursuing computer science. And then the pie chart next to that shows that the majority of the jobs are actually in computer science. So you've got a sliver of students studying the areas where there's the biggest job need.
That's scary to me.
And yeah, I'm going to let you talk a little bit about your experiences with that here recently, but this second slide talks about how that problem is continuing to grow. We look at the amount of jobs that are unfilled right now. Within 5 years, we're looking at 1 million unfilled jobs in computer science. So share a little bit about, your experience with just trying to find talent here in the Valley.
Yeah, it's hard. I really don't like the idea of poaching, so going to other companies, looking for people to steal from other companies, that doesn't do anybody any good. So it's thankfully recently we had an old employee that left us a couple years ago, came back while we were looking and said, "Hey, can I have my old job back?" And sure enough, I said yes, because he's awesome and I'm really happy to have him back. So it's really difficult. I actually went on to LinkedIn, found all of the web developers that I could find, sent emails out to everybody, and most of them said that they were happy where they were, and finding anybody out there that wasn't already tethered was impossible.
Yeah, it's tough. Well, and I think these statistics really bear that out. So last thing of statistics of the workplace, wanted to talk a little bit about girls in computer science, and the statistics of how many girls are getting into computer science majors and studying CS is pretty well aligned with the amount of girls that we actually see in the workplace. I was interested when I asked you what your ratio was. You've got 20% female employees, but frankly, very few of those are doing actual coding, if I understand it correctly.
Yeah, we don't have any girls that are coding. Most of them are illustrators, animators. We've got a project manager, an office manager, and there's nobody on code.
So a lot of opportunity for girls out there. This slide, again from code.org, is showing you the number of students, which again is not enough students going into computer science, but an even smaller amount of those are female. So that little yellow sliver at the top of that bar is the amount of girls that are going into computer science. There was a great interview just last night that was released on fortune.com with Megan Smith, who's actually the U.S. Chief Technology Officer. And it was very timely. I was putting together the last slides on this presentation, and this popped up, and I thought, wow, that's fabulous, because this is a leading STEM advocate, a woman, and she's got some ideas about what we can do to encourage girls in STEM, which I have highlighted there on the slide. The Fortune article is simple to find. Just look for Megan Smith and Fortune. It literally was just posted last night. It's an interview of several women that are talking about getting more girls into the technical workplace. So now, with just a few minutes left, I wanted to actually talk about, how do we start getting computer science into the classroom? A lot of you who are attending probably are interested in, okay, we recognize that there's a need, there's a lot of value to it, but how do we do it? So PCS has been doing computer science education for a long, long time, clear back into 86 when we got started. So the things that we have learned about computer science, I think, are very important to pass on. One of the most important things, if you're going to be brand new and you've never done any computer programming or typically any applications with your students, if you've not done anything like that, preparation and testing and experimenting is critical, because things go wrong. Again, it gets back to that failure-based education, which we want students to learn from failure, but we also want to make sure that things are functioning well enough that your classroom can run. So on the right-hand side here of this slide, there are some different topics that I'm going to talk about in the next slide. These are examples of some of the things that we use to get computer science introduced into our labs, and then also subject areas that we have curriculum in. On the left-hand side, one of my heroes is our robot, RIQ. And we're actually going to take a look at RIQ and the computer programming environment we developed for RIQ. A big piece of success in the classroom is engagement. So on the left side of this slide, it says begin gently underneath there. We don't recommend you dive right into hardcore text-based coding with your fourth graders. What you want to do is get them excited and interested and engaged at the beginning. It's that comfort level, it's the fun level, and that's what will get your students drawn further into something where they can actually get to the level of rigor that Randy discovered. If it hadn't been fun, I doubt that Randy ever would have pursued it to the depth you have.
It's got to be fun.
Yeah. So the topics, for example, that I just mentioned, these are some of the things that we recommend as great ways to get started for computer science in the classroom. And these are targeted primarily at elementary, although they apply to higher levels as well. A lot of the materials we've developed fit into multiple environments. So not just the traditional classroom, but your after-school environment, maker spaces, running a Boys and Girls Club. There's so many different environments that computer science can fit into now, and it's a great application, for bringing educational topics to life. So the 5 I've got listed, robotics is one. We're actually going to take a look at a robotics programming environment for just a moment. 3D design, that ties into some of the art aspects. This is a great way to draw more girls into it as well. We use a program called SketchUp for introducing 3D design. So these other topics that I'm mentioning, by the way, this is all free software that's freely available. So there are topics that you can get involved in implementing into your classroom that aren't going to cost you anything. If you're going to do robotics, obviously there's materials you have to buy. If you're going to do 3D printing, you've got to have a 3D printer. But a lot of these resources are free and available for you to get started. Other topics, multimedia. There's an environment called Scratch that was specifically designed to get kids into programming environments, and they do it around building multimedia experiences. It's a friendly drag and drop environment. The system was developed by MIT and a group of educators that spent a lot of time thinking about how to develop computational thinking skills in students. 3D printing, of course, is great fun because you can tie your abstract code to something physical, and that is very exciting for kids. Here again in our lab, we do things like, for Halloween, for example, we're doing something called Zombie Month, where students are working in teams to actually create 3D zombies that they print, and then they will actually do like video productions as a team. So it pulls in all of the art and technology to actually produce a final movie with visual effects and those kinds of things. The final topic there is called Unity, which is a gaming environment that we also introduce students to. Many of the games that are on the market are actually developed in Unity. So we're teaching kids an environment which is relatively easy to get started in, has very high top end, but you can get students started with a drag and drop environment where they're actually creating 3D environments that give them insight into how the games that they play after school are actually designed. So with that in mind, I'd like to do a quick demonstration of what we call beginning gently using our robotics programming environment. And we're going to switch, I think, screens here. It should pop up in a second and give you a quick demonstration of how the Cortex, our programming environment, works. While Samantha's getting that up, I'll point out that this programming environment was actually developed by Curious Media and Randy Jameson. So he's come full circle in terms of PCS. He's now actually developing the software that we use with students, and he's got great insight into what we need for the students because he's actually been one. So the image that is on the screen, is it displaying correctly? Okay. Is our actual programming environment. You'll notice it's very colorful. These things look like little puzzle pieces that you can drag around with your mouse. On the left-hand side, we've got a color-coded menu where different items and commands live, okay? So very friendly and approachable. There's no written code that you have to worry about. It's more like dragging puzzle pieces around. I'm going to show you a very simple program that is a robotics program that would turn on 2 motors on the little robot I showed you. He has a little robotic controller that you can plug motors into, and he has actual 4 ports that you can plug 4 different motors into. From the motor command menu over here, I've just dragged over a command that says motor A, which would address motor port A. I'm going to select 2 motors because I want my robot to have a couple different things going on. You can see how easy it is to change that. So now there's the beginning of my program. This is the beginning of understanding program flow. So the first thing that happens is I address motor port A and B, and I want something to happen on motor port A and B. I'm actually going to turn them on for a period of time. So I'm going to go over here to where some of our number operators live, sensors, numbers, and I'm going to drag this little number over here and attach it. And the number represents tenths of a second, which is great for introducing students to applied fractions. So if we do 40, that's 4 seconds. That's applied fractions right there. And then I put the end on in there. Boom, we have our very first program, and very simple to build. It's going to address motor port A and B. It's going to turn them both on for 4 seconds, and then it's going to end. The next step for a student would be to download that to their, oops, hang on just a second, would be for them to download that to their robot, turn it on, and watch it happen. And that's one of the exciting things about robotics. We can switch back over now if you would, please. That's one of the exciting things about robotics is it ties coding, something very abstract, to a very physical action. You can see immediately that, wow, that works. I just made something happen. And that's one of the reasons that we focus heavily on robotics at PCS, is because we see those aha moments more frequently. So that's an example of coding in the classroom that's very simple. You know, these environments, especially Scratch, are based on that same method where you're dragging and dropping, very approachable, very simple ways to get started in understanding computer programming and actually seeing an output. This next slide talks a little bit about our approach to actually helping you apply that in the classroom. So we've developed curriculum. We have a series of different topics that I just mentioned, and they're all executed through a couple different ways. We have 2 different types of curriculum. One's a very rich experience where students are building portfolios and going through inquiry-based experiences. The other is a more granular approach that we call lab cards. And the lab cards are fantastic for somebody who's just getting started, because each card you can pull out of there as a student. You can actually see step by step what you need to do to get started doing what, for example, I just showed you. And it also takes a student through that learning curve of experience and experimentation. So it's not just step by step. The first thing we show them is, you know, step by step how to accomplish something, but then we take them to the next step where they are challenged to extend upon that knowledge. And then each series of activities, little micro activities, concludes with their own personal exploration or invention. So these lab cards I love because as we've tested them in the lab, they really give the student the ability to drive the experience, and it provides the educator with a lot more ability to facilitate the experience. So some students are going to go faster, some slower, but the goal is to provide them with a very differentiated experience that allows them to learn programming or 3D printing or SketchUp, whatever that topic might be. This is another slide of another lab card. This actually shows you at a glance the kinds of things in the topics that are going to be addressed, so that when you conclude this webinar, I've got a resource page. You can actually go down or go to our website and download some of our examples, and you'll see these in action, which is a much better way to understand what I'm explaining. But again, the purpose is to provide an educator with a very simple way to execute the beginnings of computer science in the classroom. So this last slide, I've got a few resources on there for you. There's the link for you to download samples. I've also listed out some of the major computer science standards, the resources that are out there. There's the Computer Science Teachers Association, CSTA standards, and then ISTE, International Society for Technology Education, also has computer science standards. Both of these sites are incredibly valuable for providing you insight into, what are the things that we're trying to teach students and what kind of knowledge should they have to become technologically literate with computer science. The other sites that I've listed there, code.org is incredibly valuable because it provides not only background and educational research as to why coding is important. Some of the things about the statistics I showed you came from code.org, but it also gives you a platform and a lot of tools. Again, a free system that can let you get started in the classroom. National Computer Science Month, Computer Science Week, is in December, and there are a lot of activities going on around the country. A lot of people are using code.org. They're participating in something called the Hour of Code, which gets students introduced to a lot of the things we've been talking about in a very fun, very low-cost manner. So I'd recommend going to code.org and learning about those. And then the last resource I've listed there, National Science Foundation. This is an article that they've put together that they call a Future of Computer Science. But it's got a lot of good links to resources, research, as well as curriculum that you can apply at the high school level, things that are going on at all grade levels throughout K-12, and has a really good picture of a lot of the things that we're trying to accomplish as a nation to get more computer science literacy into the classroom. So with that, I'm going to move on to questions and answers. I think we've got about 10 minutes left. Before I do that, did you have anything else you wanted to add? Nope. Okay, let's go on to the Q&A.
All right, thanks, Robert. We've got 3 questions so far. If anyone else has questions, please type them in the question box and we'll be sure to answer those as well. The first one is actually from another Randy from Boise. My mom thinks computers are for playing, not educating. How can I convince her otherwise?
Great question. I'll let you take that one.
Well, you can convince her by, by using a computer to make something instead of just playing it. There's a huge difference between playing a game and making a game. And if you really like playing games, which I do, but I actually would prefer making them than I do playing them. So I think, yeah, I would say convince her by making something.
That is a great suggestion. The other thing I'd say, Randy, is those some of the tools we just talked about. If you look up Scratch on the internet, Scratch again is a free programming environment that's really simple to get started in, and you can create multimedia experiences. And that's the environment you could use with no cost to actually build something to show your mom how important it is. I think making something's a great idea.
And on top of that, that would fit right in with what I'm looking for as an employer is, what are you doing on your free time? Are you making stuff on your free time? And that is going to show your future employer that you're passionate and that you're talented. Because if I had the free time that I had when I was 15 or 16 to just make stuff, and I had the technology that we have today at my fingertips, I just very sad about that. I need a time machine. Go back and make stuff at a younger age.
All right, we have a second question from a Graham Fulmer. Can you 3D print a pivot point on your zombie figure or figures in general?
Yeah, absolutely. 3D printing is remarkable technology that continues to get better and better. In fact, when we prototype robotic components for our systems, we 3D print them here in our lab. One of the things we built was a 3D pivot point for our robot so you could spin on a dime. So yeah, very easy to do.
All right, third question is from a Tony Jungberg. What is the youngest age you would get kids working in coding?
I would get students started in kindergarten, frankly, because there's so many simple tools to actually build, computational awareness even at that age. And it's playing, but it's introducing them to an environment that's going to be part of their life going forward. So, in fact, I think you actually own one of the, what are they called now? The little rolling robot, which is more for a kindergarten student.
Oh, yeah, Dash and Dot.
Dash and Dot.
Yep.
Yeah, Dash and Dot, that's a robotic system that allows very young children to actually do some controlling and some basic programming for these robots that are, they're going to roll around and do stuff. So just like I was showing you with Cortex, create a little bit of code, see it happen in the real world.
Okay, We've got one from Brianna Brandon. Hi, my name is Brianna. I'm in my 20s and have little coding skills, but I'm looking to expand. I'm also very involved in education and development of female skills, especially at a younger age. Would I make more of an impact supporting students or educating myself first?
Make more of an impact. Well, I think both, frankly. The thing that I've realized by having private labs here as part of our company, we recruit a lot of students from Boise State University. A lot of them are engineering students.
I stole one.
Yeah, you don't poach. The thing that I've realized is that those instructors that we bring in who are students, while they're learning at college, they're learning much more hands-on in terms of, actual computer science and application in the lab than they typically are in their abstract courses. The other thing that's happening is they're impacting lives because they're young, they're passionate, they're excited about things they're working on, and they're passing that on to students. So I guess my recommendation, Brianna, would be to find an environment like that, volunteer at a Boys and Girls Club, a YMCA, and start taking the technology that you're studying. Same thing that Randy was talking about, maybe get into Scratch and learn how to build interactive experiences, but pass that on to students. There's no better way to learn than to teach because you have to know it very well.
Yeah, that's true. In my Curious Media also is we have a setup to where we have team leads for all of the different pieces, so animation, illustration, design, everything, and the team lead is responsible for teaching the other people in their team, and then let's say they teach the one that's below them in ranking something. Well, that person can then take that and teach the people that are below them, and the teaching does solidify it. So I think it's a perfect thing to be able to teach and learn at the same time. I mean, it really would solidify things.
Yeah. Any more questions?
All right, I've got one from Judy Cornelius. We are a private school and are not finding funding opportunities. Most grants are for public schools. Do you have any suggestions regarding robotics equipment?
Oh, absolutely. There's actually on our website, Edventures.com, we have a funding link at the top. And there actually is a lot of funding available for private schools. You just have to look for it. I would recommend getting on our website. The next slide actually will show you your STEM experts. We call them STEM ambassadors here at PCS that work for us in our account management. And they can actually help you track down some funding that might be appropriate for your site. Obviously, we're very fond of our robotics. We think it's probably the best way to get started in robotics, especially for elementary and to middle school ages. So that's the product we'd like you to look at, and I think we might be able to point you towards some funding that could be helpful.
All right, we've got a question from Neha Bhatt. My son loves to play on SketchUp, the free version. Is there any other like SketchUp that has more tools at low or no cost as SketchUp full version is very expensive?
Any alternatives?
Yes. So there is a free open source 3D modeler / animation tool out there called Blender 3D, and I've been using it for over 10 years, and it's really awesome and free. And you can make some. It's Maya quality. So Maya is another. That's what the professionals use, and so it's really good quality software, and there's great support. There's a good support community, lots of videos, tutorial videos, and it does have a little bit of a steep learning curve, as do many 3D, like serious 3D apps out there, but well worth it once you get the basics down. It really will help a 3D enthusiast kind of blossom for free.
Yeah, depending on how old your student is, it can be a little intimidating, and it gets back to that persistence. So don't let the student get frustrated. Like Randy says, there are a ton of great resources for Blender online. We've had students here in the lab actually pursue Blender, and I see some frustrations because it is more complex. But if you can encourage that student to push through, maybe take it in bite-sized chunks so they have some wins, it does have some incredible capabilities. In fact, you can look on YouTube for Blender 3D animations, and you'll see the quality of the work that can come from that program.
All right, from Jenny Worley. What is the ideal teacher-to-student ratio in a coding class? I'm doing a Scratch class with 20 students, and I'm a little overwhelmed.
Yeah, we recommend having more facilitation. If you can have an aide so that it's at least 10 to 1 in the classroom. A lot of it depends on how you're running your program. We designed the lab cards, for example, to help solve some of the problems with students working at different levels, because the lab cards give you very granular instruction, and students have more ability to pursue things on their own because the assistance is right there. If you're teaching a class that's more instructor-led, step-by-step, everybody's doing the same thing, that's one way to control 20 students, but it's not as effective educationally. Here in our labs, it's a private after-school program. We have a very low student-teacher ratio of like 4 to 1, which is ideal. But if you're doing 20 students, I would recommend having at least an aide, and then structuring it so that you've got some ability to differentiate, the instruction that's going on.
Question from Candace Johnson. The program I work for has access to one 3D printer. How can I incorporate that in a lesson with 40 of my students? I'm not sure how to use this tool with such a large class.
That's a challenge for sure. One of the things that we do is, students are building models all the time, and you can do things where, there's a certain level of expertise they have to get to before you let them print. That's a carrot. The other thing you can do, of course, which is what we do a lot, is scheduled printing outside of class time. So students will actually produce their models if they have achieved, the point level that they're required in our system to have access to the printer. We put them in the queue and we make sure the materials are printed. It is a bottleneck, so those are a couple of the ways that we've addressed it.
Okay, another question from Brianna Brandon. I work within an academy that promotes classical studies. I would like to emphasize the importance of computer science. How would you delicately articulate the equaling importance to a more traditional environment?
Delicately articulate that.
Say something like, snap out of it, people. Maybe.
I think that might be the approach. I guess the thing that I would do, again, code.org, those examples that I gave you of statistics that are in this PowerPoint, you're doing your students a great disservice if you're not making them technologically literate in today's society. Classical education is fabulous. I was a liberal arts student, and that's where I learned to look at things from different perspectives, have an open mind. It's where I learned a lot of my problem solving and communication skills. But the things that have made me successful, 50% of it is that approach. 50% of it was my ability to assimilate technology and understanding how technology works and drives our world. I acquired all of that from PCS after I graduated from college. So I think I would tie the workforce, the work needs, and a lot of those statistics to what those students are going to be facing when they walk out the door. If you're not preparing them, I think it's a great disservice.
Question from Stephen Willis. I represent a community-based organization, and I'm interested in funding as well. But more importantly, we are looking to set up some robust program offerings, particularly in robotics. Do you suggest a robotics product for an upstart in our Maker Lab?
Yeah, absolutely. It's the PCS robotics system is perfect for Maker Labs. In fact, the lab card approach that we developed for our robotics packages was really tailored towards an environment like Maker Labs. It works great across the board in classrooms and after-school programs, but maker spaces are perfect, especially those that may have flexible schedules where students might drop in once or twice a week, or you might have different programs that are running at different times of the week. Students can keep track of where they're at in their system by just grabbing that lab card, and they remember, hey, I left off on card number 4 last time, I'm going on to 5. So it helps you facilitate a makerspace environment which is more fluid with students coming in and out. So yeah, I would definitely recommend looking at our robotics system, which again, if you go to the link that's on this resources page, you can download some sample curriculum, and we can hook you up with an account representative that can actually show you, what our packages look like and what are included.
Which programming languages seem to work well for elementary and middle school children learning to program robots?
So some of the ones that I just described, we use the Cortex and Scratch to get students started. We teach web-based HTML, so that's a great thing to get kids started on because, again, you've got instant feedback where you see, the results of your work fairly quickly. We have students working in C#, a variety of other areas, but probably for elementary to middle school, I would recommend starting with the drag and drop. And one of the things we've done also is we leverage what's called the Arduino platform. If you want to migrate a student from a drag and drop, simple, approachable introduction into actual coding and use robotics, Arduino is a great platform for that because it migrates you from the environment I showed you, the Cortex, which is a great way to get started, into an actual coding environment where you actually are, learning line by line code to control robotic controllers. And the Arduino community is enormous. There's lots and lots of support for it out there.
Okay, it looks like that's all the questions we have for now. Briefly before everyone signs off, I wanted to congratulate Ron Burns from Bristol Boys and Girls Club from Connecticut. He won a free Discover Robotics and Programming kit for his course. We'll contact you, and thanks everyone for joining us. Have a great day.
Awesome. Thanks very much, Randy. Much appreciated. You're welcome. And folks, the map that's on the last slide there, those are the contact names and numbers for representatives in your area. Or you can just jump on our website, edventures.com. There's a chat window that'll pop up. You can ask for a STEM ambassador, and they would love to talk to you about robots and computer science. Thanks for coming.